teacher!
Hey guys, today we're going to be doing 5.3a, rearranging something called standard form, which you're going to learn today. This goes back to solving equations and using inverse operations. So the first bit is reviewing slope y-intercept form, which is the form that all of you should know. It was y equals mx plus b, and then if you remember, this m stood for slope, which was the steepness and the direction of the line. So the higher this number is, the steeper it is, and if it's positive, it goes up to the right, and if it was negative, then it went down to the right. And then the b value was our y-intercept, yeah, if that's what you said. And you take the sign of the y-intercept as well. So if it was +1, then our graph would have a y-intercept, which is where it hits the y-axis in the positive part. And then if the y-intercept was -3 or something, then it would be somewhere like down here at -3. And that's where the line would cross. Okay, so you should be very familiar with that and very good at identifying what the slope is and what the y-intercept is. And this form is the most useful equation of a line because you can immediately tell what the slope and y-intercept is just by looking at it. And then because you can know the slope and y-intercept immediately, you can also graph it immediately using the table of values like we did in 5.1, or just simply plotting the y-intercept first and then counting up as your rise or down and the run as left and right, which you've done lots of practice with in 5.2. The new one, though, that we're learning today is something called standard form, and it looks very different. It looks like this: ax plus by equals c. Sometimes you will see it in this form where all the letters will be here with 0, but we're going to stick with this for standard form. And this form doesn't really mean much, actually. It's just a common other form. The important thing to know, though, is that the a, b, and c values are integers. They're not going to be fractions. They're always whole numbers as the coefficients of the x and y, or as a constant of just a letter. And they do not represent anything. It's not slope, it's not a coordinate, it doesn't represent anything on the graph. So we're going to have a bunch of questions in standard form, 2x plus y equals 1. And the question is, determine the slope and y-intercept of the line. Because it is in standard form, I can't tell what slope and y-intercept is right away. So what we end up doing is we rearrange this equation by isolating for y. If you remember, I want y by itself, and if you're in my classes, I want it to be like in solitary confinement, and I want to bring everything over to the other side of the equal sign, which I would call the wall. So if I want y by itself, then the thing that I have to move to the other side or bring over is its friend, which is 2x. This needs to go over. So a lot of you have been really good with the switch, and you know that that's going to be negative. Otherwise, you usually do something like this: minus 2x minus 2x. So these guys will go away, and then you are left with y, which is what we want, and then the equal sign goes for where our wall is. And if you remember from powers and polynomials, 1 minus 2x they're not like terms, so I cannot combine them. It's not going to be negative 1x. It's simply left as 1 minus 2x. So this is starting to look like our y equals mx plus b form. But if you remember, m is always with the x. So I actually want to place this term first. So I'm not inverse operating anything. I'm just going to rewrite it with negative 2x plus 1, because this is still the same thing. So this becomes my final answer. So therefore, the slope is -2, and the y-intercept is 1, and that would be my final. Because again, remember that slope is always with the x value, and the y-intercept is always that number by itself. Okay, so that was example 1. Example 2, same thing. We have to bring the y by itself, but it's got other people with it. So you're still going to do the same steps. The 5x is still needing to be removed first. So I'm going to subtract 5x on both sides. And I'm left with 2y, because these guys cancel out. 5x minus 5x is 0. And these guys are not like terms. So it's negative 8 minus 5x. You could also immediately rearrange it right away, because you know that slope has to have, slope has to have the x first. That's fine. Either one is fine. And then how do I get rid of the 2 now? Does anyone remember how to do that? Yeah, you're going to have to do the inverse or the opposite. So this is saying 2 times y. Remember, if there's no sign in between, it's always multiply. So the opposite of times is divide. So I have to divide this by 2 and every other term by 2 as well. So 2 divided by 2 cancel out to 1y, or just y. Negative 8 divided by 2 is negative 4. And negative 5 divided by 2 is a decimal. But because I like seeing things in fractions for slope, because it shows the rise over run very clearly, then I'm going to leave it as negative 5 over 2. And then I'm going to rewrite the order. So it's negative 5 over 2x minus 4. That's my slope y-intercept form, and it's rearranged, which is great. So therefore, the slope is negative 5 over 2, and the y-intercept is negative 4. If you're confused, you can always pause and replay and slow it down if you're watching at a faster speed. That's totally fine, but I'm going to keep going. The next one, find the slope and y-intercept of the following line. It's still in standard form, but this time I have 3 terms on the wall side and 0, which is nothing, on this side. You're still doing the same things. I need y by itself, and remember, y needs to be positive. So I need to get rid of this 3x and bring it over. And I also need to get rid of this 2. So you could minus 3x on both sides. That's fine. You can also do plus 2 and the opposite, which is subtract, and minus 2 right at the same time. Because this gets rid of that, this gets rid of that. And so I'd be left with negative y, because the sign is always before the term. So negative y, and this is already looking like mx plus b, negative 3x minus 2. And if you remember how to get rid of the negative, it's like saying there's a negative 1 there. So you can divide both sides by negative 1. This divided by negative 1. This divided by negative 1. These cancel out to positive y. Negative 3 divided by negative 1 is positive 3. X is fine. And negative 2 divided by negative 1 is positive 2. So this is my rearranged equation. And then therefore the slope is 3 and the y-intercept, or the b value, is positive 2. Okay, next question. Find the slope again. We have to get rid of which term first? We have to get rid of, the x first by subtracting x on both sides. And then x minus x is 0. They cancel out. And I'm left with negative 4y equals 20 minus x. And then how do I get rid of this negative 4? The opposite, it's not adding, because it's not negative 4 minus y. It's negative 4 times y, because there's nothing in between. So I have to divide this by negative 4, this by negative 4, and this by negative 4. So then I get positive 1y, or just y, equals negative 5 minus, is it minus actually? If I have 2 negatives divided by each other, they actually simplify to positive. Now you might be wondering, I don't get it. X over 4, what would the slope be? Is the slope x over 4? Not quite. So if you remember, the number, if x doesn't have anything, is actually 1. So if I were to rewrite this to look like y equals mx plus b, the x needs to go first, but I could write it as 1 over 4x minus 5. And this is my rearranged equation. So therefore, the slope is 1 over 4, and the b value is negative 5. So this one's a bit tricky, and it gets a lot of people. A lot of students write it as the slope is x over 4, but that's not correct. Slope is always a number, and b is always a number. Otherwise, you can't do your rise of x. Like, that doesn't make sense. You have to know how many to count up to. So that one is a tricky one, and it does come back in the homework later. Another example, this is, I think, the second last one. X plus y equals negative 8. You bring the x over to the other side by subtracting x, because that's the opposite. 8 and x are not like terms, and lucky for me, y was already positive. So y equals negative x minus 8. And so similarly to example 4, if there's a negative sign in front of the x, then that number is actually negative 1. So my slope in this case is m equals negative 1, and then all of you should know that the b value is negative 8. So again, just be careful if there's no number, it's always a 1 there. Next one, 9x minus 5y plus 15 equals 0. Anytime it's equal to 0, you're going to have to bring, I have to bring the 9x over, and I have to bring the 15 over by doing the inverse, which is, in this case, both of them are subtract. So you can do that all in one step, minus 9x here, minus 15 here, and then on the other side of the equal sign, I have to do the same thing, minus x minus 15. And if you still need to keep drawing your wall, that's okay too. You can keep doing that. So I'm left with, these guys cancel out. So I'm left with negative 5y. And then 0 minus all this is just that. So I'll rewrite that. And then how do I get rid of the negative 5y? The negative 5. And again, the inverse of that would be division, because it's multiplying right now. So the opposite is dividing by negative 5. Divide by negative 5. Divide by negative 5. So y is equal to, the two negatives cancel out to be positive, but 9 over 5 will stay a fraction because you're going to get a decimal. And then negative 15 divided by negative 5 would be positive 3. And this is my rearranged equation. So therefore, my slope is 9 over 5, and my b value is positive 3. The last question, are the following lines parallel, perpendicular, and neither? Is a bit of a refresher from 5.1. For two lines to be parallel, what did the slopes have to be? Does anyone remember? So parallel, the slopes had to be the same, and most of you were really good with that. For perpendicular though, the slopes, this was causing some people problems. The slope had to be the negative reciprocals of each other. So you had to switch the signs, and you also had to flip the fraction. And neither would be the slope is not the same or the slope is not negative reciprocal. So we're going to see these two equations to see what happens. They are both in standard form, so we have to rearrange it doing the same steps. The x has to go over, and the negative 6 has to go over. So the opposite of this would be subtracting x, and the opposite of subtracting 6 would be adding 6. And you can do that all in one step. And I would be left with, these cancel out, 3y equals negative x plus 6. And then to get rid of the 3, I have to do the opposite, which is division. So divide this by 3, divide this by 3, divide this by 3. 3 will cancel out to positive 1y, or just y. And then we have negative x over 3 plus 6 divided by 3, which is 2. Now again, we're close, but if at any time you see the x on the top, remember there is the imaginary 1 there. So I would strongly recommend, especially if you're confused, to rewrite it as negative 1 over 3x plus 2. And so that's my final rearranged equation for the first one. The second one's a bit easier. I only have 2 terms. I still bring the x over to the other side by, in this case, subtracting 3x on both sides. Subtract 3x. 3x minus 3x is 0, so those cancel out, and I'm left with negative y. Just be careful. Some people always forget that. And then to get rid of the negative sign, I have to divide or multiply both sides by negative 1. So negative divided by negative is positive, so I'll get y, and negative 3 divided by negative 1 is positive 3x. So here is my equation. And just in case you were confused in 5.1, remember, if there is no b value here, it doesn't mean that the y-intercept doesn't exist. It means that the y-intercept is actually 0. So if I were to graph it, it crosses through the origin. Oops, that was terrible. Crosses through the origin like that. Okay, and then goes up 3 and to the right 1. So we have to look at our slopes to see whether they're parallel. They're clearly not parallel because they're not the same, but there is a relationship. Let's check if it's perpendicular. Are the lines opposite? Yes. One of them is negative, one of them is positive. And have they flipped the reciprocal of the fraction? Yes, they have. 1 over 3 flipped is 3 over 1, and we all know that 3 over 1 is the same as positive 3. So therefore, these lines are perpendicular to each other. And that's the 5.3a lesson of rearranging equations.